Namaste to everyone. I welcome you all in my YouTube video channel. Today, I will deliver lecture on trigonometry degree level, de Moivre's theorem, lecture number 2, in which I will prove de Moivre's theorem for negative integer and fraction as index. Before proving this, I would like to give you some basic concepts. Number 1. Cos minus theta equal to cos theta. Number 2. Sin minus theta equal to minus sin theta. Number 3. If x to the power n equal to k be any real number, implies that x equal to k to the power 1 by n, then x has a number of values. For example, x square equal to 4 implies that x equal to 4 to the power half. Therefore, x equal to plus 2 and minus 2, two values of x. Similarly, x cube equal to 1 implies that x equal to 1 to the power 1 by 3. Then x has three values. X equal to 1 omega square. In this way, if x equal to k to the power 1 by n, then x has a number of values. Number 4. Cos 2k pi plus theta equal to cos theta, and sin 2k pi plus theta equal to sin theta. K is an integer, z be the set of integers. Number 5. If GCD of A and B equal to 1, then A and B are relatively prime. GCD means greatest common divisor. That is also called HCF, highest common factor of A and B equal to 1. Then A and B are said to be relatively prime numbers. Example, 4 and 9 GCD, HCF equal to 1. So 4 and 9 are relatively prime numbers. But GCD of 4 and 6 equal to 2. HCF of 4 and 6 is 2. Then 4 and 6 are not relatively prime numbers. In the previous lecture, we have dealt two cases, case 1 and case 2. In case 1, we have proved the de Moivre's theorem for zero integer. In case 2, we have proved the De-Moivre's theorem for positive integer. Now, we will prove case 3, in which we will prove De-Moivre's theorem for n is a negative integer and theta is any real number. Let n is a negative integer and let n equal to minus m, where m is a positive integer. If m is a positive integer, then if we apply negative sign here, then it will be changed into negative integer. For example, let 2 is a positive integer. If we put negative sign here, then this integer will be a negative integer. Now, cos theta plus I sin theta whole to the power n equal to cos theta plus I sin theta whole to the power minus m. In place of n we write minus m, and this will be equal to 1 by cos theta plus I sin theta to the power m. This equal to 1 by m is a positive integer. So from case 2 we get value of this is cos m theta plus I sin m theta. Since m is a positive integer, and this will be equal to 1 by cos m theta plus I sin m theta. If we multiply numerator and denominator by cos m theta minus I sin m theta by cos m theta minus I sin m theta. Here a plus b, here a minus b. Formula is a square minus b square, and in numerator we get cos m theta minus I sin m theta. Here cos m theta whole square minus I sin m theta whole square implies that cos theta plus I sin theta whole to the power n equal to cos m theta minus I sin m theta by cos square m theta minus I square sin square m theta, and this will be equal to cos m theta minus I sin m theta. Here cos square m theta minus I square means minus 1 sin square m theta. This equal to cos m theta minus I sin m theta by cos square m theta plus sin square m theta. This is equal to cos m theta minus I sin m theta by cos square m theta plus sin square m theta equal to 1. We may write this as cos minus m theta. Cos minus m theta means cos m theta. Here we also write plus I sin minus m theta. Sin minus m theta means minus sin m theta. Here minus sin. We may also write this as cos minus m theta plus I sin minus m theta. Since minus m is n, so this will be cos n theta plus I sin n theta. Therefore, theorem is proved. For n is a negative integer. Now we deal for case 4. Here n is assumed to be a fraction, that is n equal to p by q. Q is a natural number, p is an integer. Modulus of p and q are relatively prime. We have to prove that cos theta plus I sin theta whole to the power n has q number of values, one of which is cos n theta plus I sin n theta. Now we prove this. Since here n equal to p by q, therefore cos theta plus I sin theta whole to the power n equal to cos theta plus I sin theta whole to the power p by q. We may write this as cos theta plus I sin theta whole to the power p and whole to the power 1 by q. Here we see that the power is 1 by q. So this expression will have q number of values, which has q number of values. That is cos theta plus I sin theta whole to the power n equal to cos theta plus I sin theta whole to the power p by q has q number of values. Let cos theta plus I sin theta whole to the power p by q equal to cos psi plus I sin psi, where psi has q number of values. Implies that cos theta plus I sin theta to the power p by q whole to the power q equal to cos psi plus I sin psi whole to the power q implies that cos theta plus I sin theta whole to the power p by q multiply q equal to, here q is a natural number, so this will be cos q psi plus I sin q psi. Since q belongs to n be the set of natural number, implies that cos theta plus I sin theta whole to the power p, q cancel, equal to cos q psi plus I sin q psi. Since p is an integer that may be positive or negative, in both cases we have seen that cos theta plus I sin theta whole to the power p equal to cos p theta plus I sin p theta. This equal to cos q psi plus I sin q psi. We may write this as cos 2k pi plus p theta plus I sin 2k pi plus p theta. Right side will be cos q psi plus I sin q psi. Here k equal to 0, 1, 2, dot q minus 1. Since psi has q number of values, so this side we take q number of values by putting k equal to 0, 1, 2, dot q minus 1. Here we see q numbers of values of k, implies that q psi equal to 2k pi plus p theta, k equal to 0, 1, 2, dot q minus 1, implies that psi equal to 2k pi plus p theta by q, k equal to 0, 1, 2, dot q minus 1. Let this is number 1, this is number 2. Using 2 in 1, we get cos theta plus I sin theta whole to the power p by q equal to cos psi means 2k pi plus p theta by q, 2k pi plus p theta by q plus I sin psi is 2k pi plus p theta by q, k equal to 0, 1, 2, dot, q minus 1. This is number 3. Here we see that number of values of cos theta plus I sin theta whole to the power p by q be, here putting k equal to 0, 1, 2, q minus 1, q number of values, q, putting k equal to 0, we get 1 of the values equal to cos 2 multiply 0 multiply pi plus p theta by q plus I sin 2 multiply 0 multiply pi plus p theta by q, which is cos p by q theta plus I sin p by q theta. Therefore, cos p by q theta plus I sin p by q theta is one of the values of cos theta plus I sin theta whole to the power p by q, putting p by q equal to n, we get that cos n theta plus I sin n theta is one of the values of cos theta plus I sin theta whole to the power n. Here in place of p by q we have written n. Here also n. Therefore, theorem is proved. In this case, if in the examination, if you get the question like this, state and prove de Moivre's theorem for rational number, then you write the statement as if n is any integer, positive, negative or 0, then cos theta plus I sin theta whole to the power n equal to cos n theta plus I sin n theta. And if n is a fraction, then cos n theta plus I sin n theta is one of the values of cos theta plus I sin theta whole to the power n. and you will have to prove all the four cases for n equal to 0, for n a positive integer, for n a negative integer, and for n equal to p by q. You will have to prove all the four cases. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button and do subscribe my YouTube channel. Thank you.